I just want to quickly go over the format for today and then hand it over to Michael here in just a second. Michael will talk for about 35 minutes. He's got a series of slides which he will take us through. And at the end of the slides, we'll have a Q&A. Now, if you have questions during the presentation, I recommend you IM the questions. What we'll do is we'll collect them, and then we'll go through those questions at the end of the presentation. Try to keep the questions focused to UCMA 101. We're not here to talk about how to install Lync server or about the client SDK or any other Lync aspects. We will try to focus on the core topic for today. And with that, I'd like to hand over the forum to Michael. Michael?
Thanks, Tony. Can everybody hear me okay? How's the sound?
Good. Sound good on our end.
Okay, great. So as Tony said, I'm going to talk today about UCMA 101. So how you can get started with UCMA development. And I'll show you the agenda here for the presentation. So I'm going to start by talking about what UCMA is and what you can do with it, some of the basic development concepts that you use, such as the common classes that come up a lot in UCMA development. Then I'll talk about startup and shutdown. So there are certain things that you need to do in nearly any UCMA application when you're starting out to prepare to connect to Lync server, and then to clean up resources when you're shutting down. Then I'll talk about some of the things that you can manage with UCMA, so conversations and calls, as well as presence. I'll also give you a few notes about troubleshooting, so there's some common issues that tend to come up when people are starting out with UCMA development, so I'll go over a few of those. And then I'll wrap up with some resources you can use to learn more, and then we'll take questions. So what is UCMA? UCMA stands for Unified Communications Managed API, and it's pretty much what it says it is. It's a managed code API that you can use to build UCMA applications. So specifically, the types of applications that you can build with it are middle-tier applications. So they don't replace the Lync client, they don't replace Lync server. They sort of sit in between the two. And you can use UCMA to basically extend Lync in different ways by interacting with both Lync server and Lync users. There are overall 5 categories of things that you can do with UCMA, things that you can manage. So instant messaging, audio or video calling, presence, contact lists, and conferencing. I won't have a chance to go into detail on all of these in this presentation, but I'll show you some resources later that have a lot of great information for learning more. Another way I like to think about UCMA is that UCMA is to Lync server what ASP.NET is to IIS. So if you think about Lync server basically takes in requests and figures out where to route them, keeps track of people's presence and other information like that. But if you want to write an application that actually receives and responds to requests that are sent to it from Lync server, that does something with those messages, you can use UCMA to build something to do that. Now, if you think about ASP.NET, one of the things that ASP.NET does is it abstracts away a lot of the lower level details of building a website, like dealing with the HTTP protocol and managing connections and things. So in the same way, UCMA takes care of a lot of those lower level details for things like building messages, managing the connections with Lync server, and authentication and trust relationships, so that you can focus on building solutions to your business needs. So things you can build with UCMA. IM bots, if you're not familiar with the term bot, basically we're talking about something where you can send a message to it asking for information and it will respond to it automatically. So you can think of, for example, a weather bot where I can IM it and say, what's the weather today in Toronto, and it will respond with that information. IVRs and auto attendants. So IVR is interactive voice response. This is a system where you can call in and you can perform actions with speech recognition or phone keypad entry without actually talking to a person. Call distributors. So if you think of what Response Groups does, these are applications that do similar things, take in calls and figure out where to send them to Lync users or other locations. A few things UCMA doesn't do. You can't use it to replace the functionality of the Lync client or extend a Lync client. If you want to do that, then you can check out the Lync 2010 SDK, or the Lync Client SDK as it's sometimes called. Also, if you want to change the routing behavior of Lync, or if you want to intercept messages as they're going through the front-end server and modify them or reroute them, then you'll want to use the Lync Server SDK. You can download that as well on MSDN, and it's a bit more complicated, but it does allow you to change routing and change messages. So some of the requirements for developing with UCMA. The latest version of UCMA is 3.0, and you can download the SDK at this link that I have here. Now, UCMA 3.0 is designed for .NET 3.5. It does not support .NET 4. It's also a 64-bit only API, so when you're building projects that use UCMA, make sure you're targeting .NET 3.5 and 64-bit CPUs. If you target 32-bit, or if you're using .NET 4.0, when you start your application, you'll get some sort of mysterious errors, and they can be a bit challenging to troubleshoot. So something to check. Most things you can do with UCMA do require Lync server, and you'll often also require a dedicated application server. So unlike some other APIs that you may be used to, there is a bit of environmental setup that you've got to do before you can really do any development and testing. Now, most of the time you can use your development server as an application server for debugging, so you just need to set it up beforehand. Now, when you're setting up your application and setting up your server, there are some steps you need to go through to essentially identify your application to Lync as a trusted application. And that's referred to as provisioning. So I'll show you some of the details of that later. You do it for the most part through Lync Management Shell. As you may know, Lync uses a protocol called Session Initiation Protocol, or SIP, to communicate. It's a fairly standard protocol for unified communications platforms. There are a couple others out there, but SIP is one of the more common ones. And it's defined, protocol is defined in a document called RFC 3261. It's put together by the IETF, and you can check it out at this link if you're interested. Now, Lync Server adds some extensions to SIP for things like presence and conferencing. And the specification for the Lync dialect of SIP is at this second link here. Now, Lync Server's variety of SIP is close enough to the standard that Lync can pretty easily interoperate with other SIP-based platforms for things like audio calling. One key difference is Lync does SIP over TCP or TLS rather than UDP, which is the default for most SIP-based platforms. Now, if you're interested, and I highly recommend doing this, you can use the OCS logger tool on your front-end server or on your application server to see what the SIP messages look like as they're being sent from your application. So you can run OCS logger, you check the S4 and SIP stack logs, and you run your application, have it do something, and you can see what messages are being sent and received. It's definitely not necessary to understand SIP and to look at these messages in order to develop with UCMA, but it can be helpful for troubleshooting to know what's going on under the covers. So some of the basic development concepts in UCMA. The collaboration platform class is the foundation class for any UCMA application. There's generally one per application, and it manages a lot of the shared resources that are used by your application, like connections to Lync server, trust relationships, and also if messages come into the application's listening port, the collaboration platform will figure out which of your endpoints should handle that incoming message. There are two types of collaboration platform, client and server. Client platforms are mostly for things like load testing, where you need a large number of simulated users. More often you'll find that you use server platforms, and server platforms can do a number of things that client ones can't. So they can be trusted by Lync server, allowing you to perform certain privileged operations. They can use connection sharing, and they can also in general handle much larger volumes of calls across a wider range of media ports. So they're more scalable. Now, when you start up your collaboration platform, you need to provide it with some settings to tell it how to communicate with Lync server. And there are two ways to do this. You can provide them manually through your application code, maybe pulling them from a config file, for example, or you can use an approach called auto-provisioning, which is what I recommend using most of the time. It's a lot easier. What you do is you give your collaboration platform and application ID, and it uses that to pull the settings it needs from the Lync management store. So your application server will need to have a local replica of the management store, which is something you set up when you're doing your initial provisioning. And so the main reason why you might not be able to use this is if you don't have that local replica installed. Otherwise, it's generally easier. Another important concept in UCMA is endpoints. These are the part of your application that actually send and receive messages, communicate with Lync users and Lync server, and do things. You can have multiple endpoints per application or just one, depending on what you're doing. And your connections can be pooled so that if your endpoints aren't sending messages all the time, you can make the most efficient use of your connections to Lync server. There are two types of endpoints. Both of them inherit from the local endpoint class, and they're called application endpoint and user endpoint. And they're similar in a lot of ways in the way that they behave, but there's some key differences in what you can do with them. User endpoints are primarily for applications where you want to perform actions on behalf of Lync users. So if you think about Outlook Web Access, for example, in the upper right corner there's that section where you can sign in and you can set your presence or send IMs to people. That's the type of application that you would build with a user endpoint or user endpoints. So each user endpoint represents a single Active Directory user that is Lync enabled. And because of that, user endpoints can't perform certain trusted operations like joining a conference invisibly to provide a service. However, they can perform some operations that application endpoints do not have access to that are tied to a single user, like contact list management and some easier methods of publishing presence updates. Application endpoints are for creating highly available and scalable applications that provide some sort of service to users, whether they're internal or even external. So your IVRs or IM bots that I mentioned earlier. They can only be used with server collaboration platforms, and they don't correspond to an AD user. They correspond to an entity in the Lync management store called a trusted application endpoint, which you can create through Lync Management Shell. The way that Lync handles routing to application endpoints is also a bit different. As you probably know, if you sign in to Lync from multiple devices as a single user, and you send a message to that user through Lync, Lync server will actually branch that message, or fork it as it's called, to all of the endpoints where that user is signed in, so you can answer it from any of those locations. If you send a message to an application endpoint, on the other hand, Lync server will look at all the instances of that application that are currently active and running, and will send the message to one of them, so you can effectively load balance the requests across multiple servers to make your application more scalable, and also to allow you to take down one of the servers at a time for maintenance. So as I mentioned, there are trusted operations that application endpoints can perform that user endpoints can't, like impersonating users or joining conferences invisibly. And they can also be something called a default routing endpoint, which basically means that if a message comes into your application's listening port and it's not addressed to any specific endpoint that your application is managing, it will default to your default routing endpoint. And there are a couple reasons why you might use this, which I won't go into now, but if you're curious, you can ask during the questions or post on the forums. So I want to talk about the startup and shutdown process as you're preparing your UCMA application. And so I'm going to show you some code and also a bit of the provisioning process. And I'm going to use a simple sample application, which I've called Presence Logger. And all it does is it allows you to send an IM to it, and when it gets a certain command, it will start keeping track of your presence updates. So you might do this for time and expense reporting, or maybe if you need to route calls to users so you know which ones are available for messages. So I have a class Presence Logger User Agent, which manages the collaboration platform and application endpoint. And then as IMs come in, it will create Presence Logger session objects, which manage this class called Remote Presence View, which handles presence subscriptions in UCMA. Switch here to my demo environment, and I'll just show you some things in Lync Management Shell. Now there's more to the provisioning process than I have time to show you here. There's some setup steps you would need to do for your application server before this to add it to the Lync topology and make it trusted by Lync server. But what I'm showing you here is the steps needed to configure your application in the Lync Management Store. So you would need to first run the command new CS trusted application, and you provide things like the pool of application servers that it will run on, an ID for your application, and then a listening port where your application will receive messages. And the most important bit of this is the application ID, which you'll pass in to the settings for your collaboration platform so it can pull the rest of the settings that it needs. Then if you're using application endpoints, you would also need to call new CS trusted application endpoint, and that allows you to create an application endpoint and associate it with your trusted application. So when you start up your collaboration, it will automatically notify your platform of all the endpoints that are configured for it. So I'm just going to run this sample application here so you can see what it does. And you can see it's logging the platform and application endpoint startup. And I'm going to send it a message to tell it to start watching my presence updates. So you can see things going on here. It accepted the IM call. And if I make a couple changes to my presence, and then I go send another message, tells it to stop monitoring, and then it sort of spits out all the updates that I have made to my presence while it was paying attention. Very simple application, but it shows you some of the things that you can list with UCMA. You can do presence subscriptions, you can send and receive IMs, etc. So I'll show you a bit of the code here. This is my presence logger user agent class, so as I mentioned, that wraps all the stuff to do with the platform and the endpoint. So what I'm doing here is I'm grabbing my application ID, which I showed you in Lync Management Shell, from the configuration file, for an instance of provisioned application platform settings. So this is the settings class that you use for the auto provisioning approach. And so all I need to pass in is my application ID and something called a user agent string, which is it's added into the SIP messages that are sent out by the application. It's mainly for reference. You don't need to worry too much about what you put in there. If I were using manual provisioning, I would use a settings class called server platform settings, and for a client platform, I would use one called client platform settings. But this is the easiest one to use time. So then I create an instance of collaboration platform, I pass in my settings, and then I call this register for application endpoint settings method and give it an event handler that it can use to notify me of each application endpoint that's registered for my application. So when the collaboration platform starts up, what it will do is let me know of each application endpoint, and then I can use those settings that it gives me to establish the endpoints. So next up is I call the begin start on the collaboration platform. And you can see this is an asynchronous method. One important thing to know about UCMA development is that most methods, with a few exceptions in UCMA, are asynchronous. UCMA uses the asynchronous programming model, or APM. You can find a lot of resources online about techniques for developing with this model. But in general, there's always a begin method and an end method for every operation. So the way it works is you call your begin method. That kicks off the asynchronous operation on a worker thread. And then you also pass in a callback delegate and optionally a state parameter that you can access from your callback. So then when the operation, UCMA will invoke your callback method, and it will give you an instance of iasync result. And you can access your state parameter, if you provided one, from your iasync result. In the callback method, it's necessary to call your end method for the operation that you're completing and pass in the iasync result. And this will wrap up the asynchronous operation, and it will also throw any exceptions that occurred on the worker thread. So it's also important here to catch real-time exception. Any exceptions that are thrown by one of these end methods in UCMA will derive from real-time exception. And this allows you to find out if anything went wrong during your operation, which can be as simple as you passed in incorrect settings, or you were trying to create a call and the person didn't answer it on the other end. Another thing to note here is these callbacks are actually invoked by a worker thread in UCMA. So it's a good idea not to run any long-running synchronous operations in these methods. If you need to do that, just start on another thread. That way you don't monopolize one of the UCMA worker threads. The next thing is, once the collaboration platform starts up, it's going to call this event for every application endpoint that I have provisioned for my application. So I just have one in this case, and so the event is only going to fire once. And I can grab the application endpoint settings for my event arguments, and I'm adding a few other things here to indicate that my endpoint can only take IM calls, not audio or video. And then I create a new instance of application endpoint, pass in a reference to my platform and those settings, and then I can call begin establish, another asynchronous method, have my callback here. And then once my endpoint is started up, I can do various things with it, like presence operations, receive calls. So here what I'm doing is registering for incoming IAM calls. Now before I go into the details of how that works, I'm just going to switch back over to my slides and talk a little bit about how you calls with some of the classes in UCMA. So there are a couple of key classes here that are relevant. The call class is a representation of a single communication session between your application and another Lync endpoint. So there are a couple of subclasses of call which represent the different modalities you can use: instant messaging call and audio-video call. And the call object can be a session between your application and an individual Lync user, or it can be a session between your application and a Lync conference. And this is one of the things that's slightly confusing to a lot of people when they're starting out with UCMA development, because when your application joins a conference, you're actually going to have a call represented by a call object that's going between the application and the Lync server roles that are managing that conference. So you don't have a direct connection in that case to the other users in the conference, which means if you want to send them messages or get information on them, all of that is being sort of proxied through the Lync conference. The call class also has a flow property, which exposes this object that allows you to do media operations like sending IMs or muting audio. And if you want to access things like conference information, class that does that, which is called conversation. Now every call, in order to create a call, you need to first create a conversation object. There are a couple reasons for this. First of all, in Lync, as you probably know, if you send somebody an IM, for example, in the Lync client, and then you go and call them as part of the same conversation, that'll all take place in a single Lync conversation window. And those two calls are actually tied together by Lync using a conversation ID. So that single cohesive multimodality session is represented in UCMA by a conversation object. And so you need to create that first, so that if you then add another call to the one that you've created, they'll be tied together in UCMA. Conversation objects are also your link to conferencing operations. So if you need to get the remote participants on a call, on a conference, or if you need to join a conference, you do that through properties on the conversation object. Switch back over here to the code, and as I pointed out before, the way that I register to be notified of incoming calls to my application is by calling this method register for incoming call. It's a generic method, so you specify the type of call that you're looking for, and you can call on either an application endpoint, like I'm doing here, or a user endpoint. Doesn't matter, it works the same way for both. And then I subscribe an event handler, which will be called by you when a call of that type comes in. So in the event handler, I can check out properties which I have access to from the event arguments. So here what I'm doing is looking at the initial message, which is called the toast message, to see if it's got a command in it that I expect. And if it doesn't, I decline the call using one of these rare synchronous methods in UCMA called .decline. If it isn't expected, I can go and accept using the begin accept method, on the call object right here, so that's another asynchronous method. And I've got a callback for it here that calls endix. You notice that I'm actually using a lambda expression here for my callback instead of an ordinary callback delegate. Sometimes I find this is easier to read when you're looking at simple operations like this in UCMA. And then once the call is accepted, that means it's connected to my application. I've answered the IM call, and I can do things like send messages to it. My flow object, which I mentioned before. So I call begin send instant message, and I just have to pass in the text of the message, and then another asynchronous method, so I call end send message, and that'll take care of sending the IM. One thing I want to call out here quickly is that in UCMA, any communication session is called a call. So even though it's not audio, you usually think of a call as something you do on the phone, it's still referred to as a call when you send an instant message to somebody. So again, it's a terminology thing that's sometimes a bit confusing when you're out. I want to show you one other code thing here. So this presence logger session class is the one that handles the presence subscriptions. And the way I'm making it work is with a class in UCMA called Remote Presence View. And this one sort of encapsulates all the presence subscription management in UCMA. So what I do is I create a new instance of Remote Presence View and pass in a reference to my endpoint. Again, user endpoint or application endpoint. Doesn't really matter. And I have an event handler which will be fired when any presence notification comes into my application. So a notification of an update from one of the users whose presence I'm subscribing to. Next thing I do is I create a list of subscription targets. So these are the people whose presence I'm watching. And this word entity here is basically just a term for a Lync entity that has presence. So I identify the targets with SIP-URIs, and then I pass in that list of targets to start subscribing to presentity's method on the remote presence view. And once I've done that, anytime one of those users changes their presence, it will invoke my event handler, and I can look at the notification to get information about what they changed. So it could be their availability, their available or busy or away state in the Lync client, or it could be their note that they enter in here, or it could even be their calendar information or contact card data, which are also parts of presence. And then when I'm done watching the presence of those users, I can call start unsubscribing to presentities, and I pass in that same list of SIP-URIs, and that will stop causing the notifications to come in. So that's sort of a whirlwind tour of some basic UCMA code. As you've probably seen, it's not very difficult in terms of the amount of code you have to write. You can do some operations, some Lync operations through UCMA with, really just a few lines of code. And honestly, a lot of the time, the most difficult things to get started with in UCMA are just the getting used to the asynchronous control flow and setting up your environment. A lot of the time you'll find in your applications that you actually spend more of your time on the non-Lync parts of the code because the UCMA code is really quite simple. So jumping back over to my slides, I want to talk about a few troubleshooting concepts. And the reason I want to bring these things up is because a lot of times there are a few issues that people face when they're starting out with UCMA development, and the solutions are often kind of simple, but it's not immediately obvious what you need to do to fix them. So I hope to save you a little bit of time if you face any of these things. The most common is certificate issues. If you see a TLS exception when you're running your application, there are a couple things to check. First of all, if you're debugging in Visual Studio, make sure you started Visual Studio with admin privileges. So right-click and hit Run as Administrator. The reason you need to do this is that your application will need to access the private key of your certificate that you're using to authenticate with Lync Server. And if it doesn't have access, it's going to complain with a TLS exception. You can also take a look on your Lync front-end server if you have access to it and check out the event log. The Lync Server event log will often have errors in it if there was a certificate authentication that failed from an application server. So sometimes that will have clues to what went wrong. Some common causes, your subject name of your certificate on your app server might not match your server's FQDN, or the certificate isn't issued by a CA that's trusted by Lync Server. Another thing that comes up a lot is firewall issues. Sometimes Windows Firewall, if you have it enabled on your application server, will block incoming requests on your application's listening port. So take a look at that if you're not receiving calls when you send them to your application. A couple other common issues. If you see the message failed to listen on port or address specified when you try to start up an endpoint, it probably means that there's another instance of your application running on the same server. So just check and shut down the other one. And then, as I mentioned earlier, if you get errors that say that certain DLLs are not there when they actually are, you may have accidentally built your project in 32-bit mode or targeted .NET 4. So check both of those things and try to rebuild and rerun. And finally, some resources for learning more. So definitely one of the first to check out is the UCMA SDK documentation on MSDN. It's a great source of information. It's got a lot of extensive documentation on the different classes and things that you can do with UCMA. And so if you just open up Internet Explorer and type in UCMA documentation, it'll be one of the first things that comes up. The Unified Communications Developer Center has some great articles and other resources on Lync development. And if you have questions or you run into problems and you're not sure how to troubleshoot them, you can check out the UCMA forum on MSDN. There are a lot of helpful people on there that will definitely try to answer your question. Channel 9 has some great Lync development videos, so take a look at those. And if you're interested, you can also check out my book, which covers the Lync Client SDK as well as UCMA in a lot of detail. So I hope this has been helpful in giving you a place to start and learning more about UCMA. I'll just leave you with this glossary of some terms that I talked about in the presentation. And we're going to take some questions now, so I'll hand back over to Tony for that. Thanks.
Thank you, Michael. One of the things I'm going to send over IM is a link or some links that have what we call VHDs. These are actually fully packaged Lync servers running on VHDs that have test accounts that you can use for development. So it's got a full development environment. It's got the Lync server, everything you need to bootstrap your development. As Michael pointed out earlier, that's kind of the big hurdle to get started, is actually setting up the environment. So this is kind of a turnkey environment that's available for Microsoft.com, and I encourage you to go to the links and download them and begin having fun doing UCMA development. All right. Do we have any questions? So we'll open the floor to take some questions. I see some people typing, so we'll wait for them to come in. Yeah, Alan. There is there'll be two things you can download. You can download the entire recorded session and the PowerPoint as well. And they're on the forums. Kai, will you send out the forum link, please?
Yeah, I can send out the link.
Okay, we got a question here from Tom. Michael, can you see that?
Yep, I've got the question here. So the question is it possible to respond to an incoming file transfer request using UCMA, and are there any gotchas to know about? So it's a little bit trickier to respond to file transfer requests than it is to respond to instant messages or audio calls. And the reason is that there's not a built-in class that manages that messaging for you. So the short answer is it is possible, but you need to do a bit more with the underlying messaging. And if you're interested in the details on that, there are a couple of questions on the forums that address it, and you can feel free to post another question there, and I'll be happy to give you some sample code.
Oh, cool. Thank you, Michael. Sample code is always welcome. We got some more people typing. Any more questions? Any ideas of what type of applications people in this forum are thinking about? We got another question, Steve. I was wondering how to grab a message text from the first instant message. Michael, you see that?
Yeah, so, okay. So, right, I showed in my code a little bit about grabbing your initial message when you receive an IM. And what happens there is there's something called the toast message, which is sent with the initial IM request to start the call. And so if you look at your call object, your instant messaging call object, there's a property on there called toast message. And in the toast message, you can get the body, the text body of the initial message, or if it was formatted text, you can get that. So you can grab it from the initial incoming call rather than waiting for another message to come in. Toast message property.
Yeah, and the toast is the thing that pops up on the bottom right-hand screen, the little UI. We call that the toast. It says that someone wants to send you, someone's sending you an IM. So it's part of that property that helps display that.
Yeah, the same thing, by the way, applies for outgoing calls. So if you're creating an IM to send to somebody and you want to determine what pops up in that toast message on their desktop, again, you would set the toast message property and you pass it in as a parameter. You pass in a toast message object as a parameter to your begin establish method for the call.
Awesome. Thank you, Michael. Looks like we got some more people typing. William says, we're looking at allowing non-authenticated web users to start conversations with video support. Interesting. Anonymous users.
Looks like there's
more coming.
other parts of this question.
Users without a Lync client or login. Right. In other words, you're on some sort of, you're in an internet cafe and you got a random web browser. You go to a website and you want users to log in from there.
Yeah, so the short answer here is if you're asking how you would do that or if you can do that, there's no easy way to connect video from a UCMA application to a web user that doesn't have a Lync client. If you have, for example, a kiosk, you can put the Lync client on there and use the Lync client SDK to just have the video show up. But yeah, there's no, beyond actually delving into the protocol and manipulating the media that's sent from Lync, there's no way to expose a Lync video call to a user without the Lync client.
There is something on Codeplex that's available for shareware that puts a REST API on top of UCMA. It's available for download. You're certainly welcome to look at that. Check it out.
Yeah, and to be clear, you can do a lot of other things. You can expose a lot of other things in Lync to web users without them having the Lync client. But you can't really easily connect audio to them through the browser or video to them through the browser. So the recommended method for audio would probably be, you know, if I were doing this, I would probably ask them to type in their phone number if I wanted to connect a call to them. You can definitely do IM through the browser. You can have them set their presence. All that is relatively easy.
Codeplex, I'm having Kai look up the link. Just look for a link, UCMA REST API. Yeah, there you go. There you go.
We're not sharing, so.
Yeah, I'm just saying.
Thank you. Good question.
So
Okay, so let's come back to. So there's a remote presence capability question.
Can you repeat the question?
Okay, we have a question here. With the UCMA remote presence capabilities, can we detect when a user has a call alerting, a toast appears? Or when a user starts a conversation window, is there a user state that reflects this?
That's a good question. So it sounds like what you're asking is, can you remotely find out if another user, either one that you're sending an IM to or one that you're not sending an IM to, has a toast coming up? Like, can you find out what's going on in the user's Lync client from your UCMA application? And there's no way to do that from UCMA, but what you could do is use the Lync client SDK, the Lync 2010 SDK. That allows you to subscribe to events concerning the Lync client, so you can be notified when a conversation comes in. And in theory, you could also expose a WCF endpoint on your UCMA application and have your individual users send messages saying, hey, I just got a toast. Whether that would be a good scenario would depend on what you're trying to accomplish. But yes, you can do that with a Lync SDK, but not with UCMA.
Okay, thanks, Michael. We got one here from Tom. Can you create a UCMA application for use with an Office 365 account? Or will require on-prem server? In other words, can you extend Office 365 with UCMA?
Okay, so I may be slightly out of date on this, so somebody can jump in and correct me if I'm wrong, but my current understanding is that you can't create UCMA applications that actually run on Lync Online. What you can do is you could federate with, so you can send federated messages to users that are on Office 365. So you could have an application that's hosted on premise that interacts with Office 365 users. And there are some caveats to that, I believe. I won't go into all the details here, but the point is there's some possibilities.
Yeah, so and there's a few pieces of information to add to that, right? So that is the first thing that what Michael said, you use federation and therefore you still require an on-prem deployment. That's one solution. The other thing that is what people do not realize is that if you use a UCMA user endpoint, people try to sign in into an Office 365 account with a user endpoint and will find that it's not working. The reason why it's not working is that the UCMA is actually only supporting AD credentials and not OrgID. OrgID is the authentication method that is being used by Office 365. So even if you would write a user endpoint application, it still doesn't work with the with Office 365. This is something that we are aware of. We are trying to look at ways on how to make it easier going forward, but at this very moment it's impossible.
Thanks, over.
Great questions so far. Thank you. Any more questions? We got some really good questions. Any feedback on
Suggestions for upcoming topics.
suggestions for upcoming talks? We have other talks that are posted on the forum. There's a sticky on the forum that talks about other things we've been talking about. But is there anything that anything our audience would like to see in the future as future talks? We got the Romano, I believe.
So they're using a native Lync client.
One question. If you want to do a third-party call control, okay. If you want to do a third-party call control, I would have to use UCMA and Lync client API together. Okay, Michael, you might want to explain what third-party control is. And then
It's an excellent question. So I guess third-party call control can mean a number of things. What I assume you're talking about is you want your UCMA application to be able to manage a call that's occurring between two other Lync users. So possibly start the call between the two of them, or once it's going on, do transfers or disconnect the call or keep track of it, things like that. So it is possible to do some level of third-party call control with just UCMA, and I'll give you 3 methods that you can use to do that, and you can decide which of them is most appropriate depending on your scenario. The first and simplest one is you can use something called a supervised transfer. So what you do is you call user A from your application, you also call user B separately, and then you perform a supervised transfer from user A, from the call with user A to the call with user B. And it does something called call replacement. So essentially it takes the call with user A and it puts user A in the place of your application on the call with user B. So neither of them know that they've been reconnected. One of them might hear a bit of ringing because it's a transfer, and the other one will just suddenly be on with the other user. Now the caveat here is that you can't, once you've connected the calls like this, you can't manage it from your UCMA application. Your application is no longer part of that communication session. So it's only good for connecting calls. Option 2 is you can use something called a back-to-back call. And I won't go into too much detail on that because the next Lync Development Roundtable session covers that in detail. But you can check that session out if you want to know how to use back-to-back calls to do third-party call control. And the third method, which you can see an example of if you check out the contact center sample, which comes with the UCMA SDK, is you can actually start a conference, and then you can invite both users, user A and user B, to your conference. And once you've done that, you can disconnect the call by kicking them out of the conference. You can keep track of how long the call goes on. You can even record it or play hold music or do things like that. So effectively you're managing a two-party call with a conference in the middle. And again, you can use back-to-back calls to hide the fact that you're in a conference. And I'll leave that to the next session for full explanation.
Great. Excellent. Thank you, Michael. It looks like we got Tim typing a question here. Is there any auto answer feature like on obvious switches? Now you're getting more into an application, correct?
So Tim, yeah, the answer to this is sort of yes, not with UCMA. It's something that you would do with the Lync client SDK, and you can actually have it automatically answer a call that's coming in to the local Lync client. So you would create an application with the Lync client SDK, put it on the machine, and have it pick up the call automatically. And I believe there's another roundtable session in a few weeks that covers the Lync client SDK. So
right, and I believe it's also documented fairly well in the book, right? Your co-author.
Yes, yeah. If you pick up a copy of the book, there's a section on how to do this and also how to suppress the standard Lync client interface. So if you're developing a kiosk, for example, and you don't want the Lync client to show up, you just want it to auto-answer the call as it comes in, there's a way to do that.
And I also believe there are numerous examples on the forums as well that are linked in both the deck and I posted the link earlier. We'll post them again here at the end.